वक्रतुंड महाकाय सूर्यकोटि समप्रभा निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा।
Agrawal sir, the floor is yours. Unmute yourself, sir.
Yes. Welcome, friends. We are going to see a nice presentation today. So, I welcome my Mechanization and Modern Technology Committee Chairman, Shri Sakthikumar ji, all office bearers of BAI, government officers, some architects, academicians who may have joined us, and members across the country who took interest in today's webinar. Also welcome our presentation team today, the head of Sales India from Elematic India Private Limited, Shri Sanjay Apte, Shri Vaibhav Singhal, Vice President Design from Elematic India Private Limited, who is going to present, who is our keynote speaker for today's program. I welcome you all for this webinar and hope we'll all find it very interesting. So I request Sakthikumar ji to give his opening remarks. Thank you.
Sakthi sir, you can unmute yourself.
Thank you, Sushil ji. Good evening to all who are present in this webinar. On behalf of the Mechanization Committee, I thank Sushil ji especially and Madhu ji for stitching together this presentation. This idea came up when both of them were in Berlin, Germany, where we felt it is very, very important to get the latest trend, what is happening in the mechanization field of construction industry, to be introduced or shared or discussed in detail with our members. I think three major trends which is happening in the construction industry in the last couple of years, especially after the lockdown and COVID and realization that migrant workers are not going to be available the way they were available in the past. I would like to talk about all three before I get into the precast topic. One is on telematics and IoT, which is becoming a major wave of change in all the machinery. People would like to remotely see what is happening with the project progress and maintenance and performance of the machine. And we could see many of the type of equipments are getting incorporated with this type of mechanisms now. And second, with the considering the growth of our country, especially on infrastructure, the investments, what is happening with the national infra pipeline, we are seeing the size of equipments are becoming bigger, and good old machines, which are very popular in India, when the project sites were not demanding speed or scale, or moving out of the business, and then more modern equipments are coming in. One such trend is movement of the backhoe loader to mini excavators and mini loaders, where people are seeing them as a more productive machine than an utility machine. Similarly, if we talk about concreting, one is on the boom pump, Today, India has become one of the big market for the concrete boom pumps now, post-COVID, for the same reason where there are things not available anymore to lay the pipeline, etc. And the boom pumps are becoming very popular. And similarly, precast is another topic which everybody would like to move in the future because of the various advantages inherently precast can offer to the concrete constructions at sites. I mean, I would not like to say too many things because Mr. Vaibhav is there to talk about that. But I can especially tell that in today's condition where we are challenged by weather, and you would see that in many places there were accidents involving, the construction of metro rails. Almost in many cities we saw some issues. All this can be fixed with the precast, where the quality is in a much controlled way, done it in a factory atmosphere, and then even during a challenging weather condition, erection is not a problem. Whereas if you have to do a construction in a raining period, it is not that easy to control the water cement ratio at the site using even any of the concrete machineries. I think these are some of the few advantages which is going to help the construction site. And today's topic is going to be precast, so I am anxiously waiting to listen to Mr. Vaibhav Singhal, who is going to make a presentation on this topic. And I once again thank everybody who was part of this, organizing this event in a very short time in a very nice way. I wish all the participants to have a good learning takeaway from this topic. Thank you very much, sir.
Thank you, Sakti sir. Can we have Mr. Sanjay Apte here on the screen? Okay.
I'm here. Thank you, Agrawal sir, Sakthikumar sir, and all the audience present for today's evening. A nice executive technical seminar. I have a responsibility to introduce today's speaker. The biodata is very big, but I have to trim it out, and I'll just introduce him in a few words for today's evening. Our today's speaker, Mr. Vaibhav Singhal, Vice President, Design Services, Elematic, India, is a civil engineering graduate from IIT Kanpur. He is heading the building design team, provides structural engineering and complete BIM solution to Elematic customers globally. Mr. Vaibhav, born and brought up in Alwar city, where Elematic has set up its manufacturing plant in India. According to Vaibhav, this is just a coincidence, and he got an opportunity to participate in construction of the plant in Alwar. Mr. Vaibhav is having 14 years of rich experience in structural engineering for buildings and in building information modeling, BIM. He has designed various types of precast and cast in situ RCC structures, villa, residential, commercial, office buildings, and high-rise buildings up to 200 meters height. He has spearheaded the large-scale BIM projects covering various design stages from concept design to construction stage. He is experienced in utilizing cutting-edge technologies in construction and design. He has been instrumental in guiding customers to set up precast plants, having medium to high automation that includes automated concrete distribution system, element transportation system, multi-stacing abutments, and circulation line for wall production. This is very brief introduction. I think Mr. Vaibhav will elaborate about the technology. I hand it over to Agrawal sir.
Vaibhav ji, you can, I have made your call. You can unmute yourself and go ahead. Please, the floor is yours.
All right. Thank you. Thank you, everyone. Thank you, Builders Association and all the participants today. In today's presentation, I'll do my best in terms of giving the understanding about what precast construction is all about. If anybody wants to venture into precast, then how it can be useful for various kind of projects. I'll try to also touch upon the kind of precast plants available. And then probably by the end of the presentation, you'll have clarity with respect to technology, with respect to its adoption, and we can probably have some question answer session as well. So I'll be sharing my screen now.
Okay.
Now, before jumping onto the topic for today, I'll just also talk about our company first so that you'll understand the kind of rich experience that Elematic comes with. So Elematic was founded in 1959, and they have got, and since then they have been doing a lot of precast construction technology evolution, I would say. Almost everywhere in the world, you'll find precast plant from Elematic. Almost already 4,000 precast plants have been set up all across the world. So as a Elematic, we are not just selling the construction technology, but we are providing the precast solution to the customer, which actually involves starting from the building design. Then we are doing the precast plant design, which actually would be combination like what kind of precast machineries is required, what kind of area of plant is required, and what kind of stockyard is required. So all these related information in the design we are doing. And then definitely we supply the precast machinery. The machinery can have low automation, mid-size automation, or very high automation as per the customer requirements. So those kind of precast machinery, mold and machinery we supply. Then we have a team who is also setting up the plant. And then after setting up the precast plant and when it is operational, we are also helping the customer further with respect to concrete mix design, precast element production, stockyard management, and installation. So as a Elematic in India, we are actually providing total precast solution, which involves right from concept design till the execution of the project is more of a hand-holding support. We have a complete project support team, 40 plus people in the design team, who are actually combination of structure engineers and BIM professionals. So all these structure engineers and BIM people, they are doing a lot of precast building design and other design as well, where it is combination of precast, cast in situ or steel structure. Then we have our service engineers team, and we also have our plant that is based in Alwar. So from where we are actually doing all the mold supply we are doing from India. So all the molds for column, beam, and tables and other kind of molds for precast elements, they are all manufactured in India. And the core machinery with respect to technology part, where it's a concrete distribution system, or it's an element distribution transportation system. So those kind of technology part is coming from Finland. And in a combination of technology and the mold, we are supplying the total precast plant to the customer. And obviously, we also have got a 24/7 help desk and other after sales support as well. So in India, we have engineering and BIM office in Gurgaon, Pune, and Hyderabad. So in Gurgaon, we have got the office in Pune and Hyderabad. We have team who are working from home. So it's like we have presence of design team in these 3 locations. Marketing presence as well in Delhi, Bangalore, and Hyderabad. And that way we are able to cover across India. And plant is based in Alwar, Rajasthan. And also our service team and supervision team is stationed in Delhi and Pune. So as a design team, the strength, because for any building to be a good design, to adopt the technology in the right way, it is important to have a strong structure engineering team behind this. So our design team, who are major lead structure engineers, are all graduate and postgraduate from premium colleges like IIT. And together we bring like 40 plus years of industry experience, especially in precast. So that's how we are able to serve to the customer. Our team is also doing Indian projects as well as the overseas assignments. And all we are equipped with the latest technology and the software licenses and all. So precast design services we are doing and BIM services. So other than the precast, we also provide the BIM services for the project. So now that was all about brief about the company, that what we are doing and how we can support our customer. I'll come to the precast solution that is available and how anybody can adopt precast for the project. So let's understand this precast concrete. So as a precast, there is offsite manufacturing. Broadly, we can divide this activity in two ways. One is the offsite, other one is the onsite. Now in offsite, we are producing all the elements for the buildings. These are all load-bearing members, all column, beam, slab, staircase, wall, all being are produced in the offsite setup. That is your precast plant. So you're producing those elements there, curing them there itself and storing them for some time. Then afterwards, you're transporting those elements to the site, and then the installation is being done through the cranes, and then the building is finished. So these kind of 6 stages are involved in terms of precast construction. Now, typically this question always comes in mind, that are there any limitations with respect to precast? So I would say there are no limitations in terms of what kind of project it is, whether it is a residential, commercial or industrial building, mid-rise, high-rise, or in public works. We have seen it. We have been seeing this for almost like more than 10 years now, that in all the metro projects, it's already being utilized. So precast has got no limitation. It's all about what kind of plant setup and capacity that you have. Then it's also about that what kind of crane capacity that you have at site and the logistics part of it. So as far as these 3 things are taken care, then you can do practically any building with the precast, because in terms of engineering, we can design any building with precast. All the connections can be designed accordingly, and any project can be done with this kind of a technology. So now moving forward, typically if we divide the projects, so we can simply say there are projects which are residential or which are non-residential. Now how we do this differentiation is because in residential projects, you'll see that there are a lot of walls, there are a lot of infill walls. And that's what make them a different type of design solution, because we want to take the advantage of those kind of walls as a load-bearing member. So rather than going with the column beam slab system, we can make the load the same infill walls as a load-bearing member as well. At the same time, that will also act as a partition. So in all the residential projects, the suitable precast system is that we go with load-bearing precast wall, then we have precast slab, and then staircases. And majorly, you only need these 3 elements to do the residential building in precast. And the facade of the residential building, generally, this kind of facade, that is also one of the character of a residential building, that you have to have a facade which doesn't require too much of a maintenance over the period of time, because after 5 years, 6 years, you see that conventionally in some projects, plaster is falling off, or some kind of a paint has gotten bad. So you have to do the repaint, you have to do a lot of repair work. So this kind of facade elements can also be, it can be something which can be done as part of an inherent part of the precast element. So as a structural system, we call it as a load-bearing wall frame structure, where we have a load-bearing wall at, let's say, both the sides, and then one solution in terms of slab is that we can go with the hollow core slab spanning from one wall to the another. Now, the advantage with this kind of a system is that, especially with respect to mid-rise stories like 15 to 20 story building, you don't need to practically make every wall as a load-bearing wall. So all my internal walls, I can keep them as a non-load-bearing. So the advantage that you get with this kind of a structural system, that you provide a lot of flexibility to the end user. Like this, if this is a non-load bearing wall, so I can make the changes in the partitions location later on as well. So typically the perimeter of the apartment let's say this is one apartment. So perimeter of the apartment you can keep as a load bearing wall. And then you span your slab from one wall to the another. And then internal partition walls can be done with some kind of other drywall solution. Now, so this is one precast solution. Then other solution could be that if you want to avoid pre-stressed slab, because pre-stressed slab setup requires different requirement. We'll discuss more about pre-stressed slab as we move forward in the presentation. But the other solution with respect to residential building is that even the internal walls also done with precast, and then you have a room size slab. So which is basically quite similar to what we do in an aluminum formwork system, that practically every wall in a residential building is a load bearing wall, and then you have a slab on it. One more point with respect to residential building is that especially in area where there is a lot of temperature variation throughout the year, and you want to maintain a good comfortable temperature inside the house. So with precast, you can also have insulated walls in the facade, and which will be basically having a load bearing wall from the inside, and then there would be some insulation, and then there would be some facade element outside. So this kind of a sandwich wall panel, we call them, which can also be implemented in residential project. And that will actually define good energy homes, energy saving homes, I would say, where you are able to maintain a good temperature inside the apartment, and outside it can be a higher temperature or a lower temperature. So that was about residential. Now with respect to non-residential building, when we say it, so it's about column beam structure. So if I talk about a office building, so in office building, you see that typically my column to column span is around varying from 8 meter to probably 11 meter or more. So that is the trend that is happening in all the commercial building and office building. So in this kind of a architectural requirement, we go with the precast column beam and slab system, where one solution is that I can provide the lateral support with respect to all the earthquake forces and wind forces by the central core, or wherever I have the walls available. So generally in a commercial building, you will have a lift core, you'll have staircase core wall area, and those walls basically will take care all the lateral load resistance for the building. And I can design my column beam where a column is precast, beam can be precast pre-stressed, and then I can have the hollow core slab again spanning for 8 to 11 meter or more as per the project requirement. So these slab, beam and column system would be purely designed for gravity load transfer. And for lateral load, I am able to take care the 100% lateral load by the central core or by all the shear walls that is available in the project. So structurally speaking, how the flow of forces will happen, that on top of the hollow core slab, we'll have RCC topping. So you can see that this is like after the hollow core, there is a RCC topping done across the floor plate. And that topping will tie, the topping will basically transfer the lateral force to the shear walls in both the direction. And then the shear wall is transferring the lateral load to the foundation. So that would be my lateral load path. And with respect to gravity load, my load is transferred from the slab to the beam and beam to the column, and then it goes to the foundation. So why we are doing this? Because if I don't want to make column beam connection as a moment connection, if I want to keep this as a pin connection, which makes the column production easy, the beam production easy, and then installation also become quite fast. So it's all about how we are designing it. If I have to make column beam as a moment connection, that is also possible, it can be done. But when we are designing precast buildings, so it's not only about just structural engineering alone. We also have to see the ease of production and ease of installation and transportation. So all these factors also to be kept in mind, and accordingly we are designing precast buildings. So in case of commercial building, this is the solution that we can go with a precast column, beam, hollow core slab, and the central core, or wherever the shear walls are available. Now, when the building is low rise, so I can even have multi-story precast column, and that will also further speed up my speed of construction. So those kind of things are taken care as a project specific scenario. Now, other type of building, other than residential, non-residential, we can say they are industrial building. I mean, there have been a lot of demand for this kind of projects where there is a warehouse project or a factory project. Typically, these are being done with PEB structure in steel, and the pure reason to go with steel is because of speed of construction. So even those kind of buildings which are actually single story, but their characteristic is that they are like 12 meters, 10 to 12 meter kind of a high single column. And when we want to do it with conventional cast in situ, so obviously the formwork and everything becomes too complicated, and we are not able to achieve the speed of construction. But this kind of a buildings can be very well done with precast solution. So one solution is that we do 100% precast right from foundation till the roof, where the solution could be two ways of doing it. One is that I can have, again, the perimeter of the warehouse or the industrial building with the load bearing wall. Below also I can have precast foundation, pedestal and beam kind of a structure, or I can have a precast strip footing divided in pieces, and then I can start my pedestal wall, and then from there the load bearing wall. And internal I'll have again column beam structure with the span whatever is required. Generally this span can be again probably around 16 meter or so. So this kind of a precast system we can adopt. The only challenge here is that obviously the moment I go beyond 12 meter of the precast elements, then the logistics become more complicated, in a way that then it's preferred that you keep those kind of production of elements near to the site, so that the transportation and all is not that much of a problem. So in that case, you have this kind of a 60 meter long beam, and then in the other direction, also you can have this kind of a, I mean, you can have this kind of a beam where you can see this is basically, this beam span can be even up to 30 meter. So in place of steel beam, you can have this kind of a precast RCC beam, which can also be pre-stressed precast beams. And in the other direction, where the span is probably 8 to 10 meter, you can span a double T slab or some kind of a hollow core slab. Those kind of options can be done. And obviously all my facade and substructure, like starting from footing, pedestal, all this would be in precast. So this is one solution. The other solution, I would also talk about the other solution in some of the examples of the project, but I'll explain you that other solution is that instead of doing roof in precast, we can just do up to this level, eave level, everything in precast. So basically my footing would be precast, and then the pedestal or the column up to the eave level is precast, and any tie beam that is coming at intermediate level would be precast. So everything up to this level is precast, and only the roof part would be done in steel. So I'll show you some example which we have done in Delhi NCR area, and it was done pretty fast, because even in the PEB structure it has been noticed like the substructure is done conventionally, and that really kills the speed of construction. So typically, I mean, if you see, we have talked about all kind of building projects, and you'll see that in all the building projects, my type of element is only 5, I mean, so to say. So one is the slab, other is column, then we have beam and wall and staircase. So you just need 5 elements. And the precast factories are not really project specific, because this is also sometime a notion that do I have a factory only set up for a project? is no. So you can utilize your factory for any kind of building project. Eventually, you're going to use these 5 elements. And these 5 elements molds are quite flexible. And this flexibility provides utilization of same molds for various kind of projects and various size of buildings and elements. There might be some restrictions, like with respect to staircase, you might say that, okay, this tread and riser, I have to fix it, but number of steps can be variable. So those kind of limitations, slight limitations would be there, which has to be thought through. Otherwise, there is a lot of flexibility. Now, with respect to slab solution, so they are, we typically can divide precast slab solution in 4 parts. So one is the hollow core slab, which I would say is the most advanced slab solution till date. This is basically a pre-stressed concrete, and it's a product where, you know, we have removed the concrete. It's a hollow slab, so we have removed the concrete where it's not really required in a slab. So we are making the slab lightweight, minimizing the concrete consumption as well as the steel consumption with the pre-stressing. So hollow core slab is a wonderful product which can be utilized anywhere. Then we have a double T slab. Double T slab is, I would say, combination of slab, thin slab with the beams, 2 beams, as you can see. This is also again a pre-stressed product and can cater to up to 30 to 40 meter span as well. Then another solution is the half slab. Now, with respect to half slab, basically it can be normal reinforced half slab, or it can also be a pre-stressed half slab. And in this, you can consider this way, that this is more of a half precast and half cast in situ, which is done at site. So this bottom, this precast portion is also acts as a formwork. So we have to just place some props as well below the slab while we are doing the balance cast in situ half at site. So this half slab solution is utilized in residential projects quite commonly, where basically it's, if you want to go with the room size slab concept, where practically all my load bearing walls are, load bearing walls. And then we have a solid slab. So for low rise building, like 2-3 story building, we can go with a solid precast slab, or for balcony kind of elements or mid landing areas, we have this kind of a solid slab. So as per the span of the slab, as per the loading, and as per the availability of precast element, we decide that what product is suitable for a project, and accordingly project is utilize that kind of a slab system. So this was all about structural scheme, the kind of precast elements are required. Now I'll touch upon the connection part, because that is also a quite common question in everybody's mind, that how these connections are and how they will behave. So first of all, before I get into this in detail, I want to explain that all these connections, whatever we use, they are all tested connections in laboratory. It has been tested in US, in New Zealand. It has been even most of the connections now is being also tested in India. And it has been found that the performance is either equal or better than the cast in situ construction. So all these connections, I mean, if I really divide these connections in terms of their load transfer capacity, so we can term them as a moment connection or as a hinge connection. And accordingly, as per the analysis of the building, we have to see the amount of forces that is coming, and accordingly, we have to design these connections. But in terms of detailing, these detailings are quite well known, and they are given in the literatures, in the code driven thing as well, and that's how it's being followed. And these have been tested. So these are like some typical column to beam connection, which this is one is a hinge connection where column is having a corbel and then beam is resting on this corbel, and it's only connected with the dowel. So it's not transferring any bending moment, but at the same time it's transferring the shear force and any movement that is happening. So So that is hinge connection. Then this is an example of a moment connection where I want to create a rigidity at a column beam junction where I am lapping the bottom reinforcement as well as the top reinforcement. So this is a column to beam connection detail. Then this is one connection detail where column to column is being connected. So where the bottom column is having a reinforcement projecting out, and that goes inside the column above, which have basically the dowel tube. And then this connection is grouted with non-shrink grout. So this is a typical connection detail with respect to column. Now this can also be replaced with a grout-based coupler where I can have again similar dowel reinforcement coming out from the column below. Then we'll have a grout-based coupler, and then we can have a bar starting again. So these are column to beam connection details. Then with respect to wall to slab connection, is also similar to what we have seen in column to column connection, that there would be reinforcement coming out from the wall below, and it goes inside the dowel tube above. And also at the same time, we have to basically connect my wall with the slab diaphragm. So in all the slab solutions, especially with respect to any structure which is more than 3-story, we have to have mandatory this RCC topping, which is also mandated by the code. So this RCC topping is also acting as a diaphragm for my floor plate. So this diaphragm is connected with the reinforcement coming out from the wall. So there is a one reinforcement bent inside the diaphragm, and this is how the slab and beam is connected. So in this connection detail, if you see, this is like external wall connection. So you have a wall to wall connected through this dowel tube system. One reinforcement is bent inside this, and then this gap is filled with the grout, and exterior we have to put backer rod and sealant. So this sealant is basically for a protection for any kind of a possibility for the seepage because of heavy rain and all. So you can see that there's a sealant, then there's a grouting is done. So these two kind of a thing really eliminate any possibility of water intrusion. Then there are some wall-to-wall connection details. So this is like if I'm connecting these walls together with some kind of a loop connection, or I can also connect a wall-to-wall with rebar projecting out from both the side and have a more of a stitch connection. So it all depends how structure engineer is designing and what kind of forces are transferring from one wall to the another wall. And accordingly, this junction has to be designed and detailed. Similarly, some beam to slab connection detail, where my slab is resting on the beam, and then there are some tie connectors, tie reinforcements are provided with respect to longitudinal ties, with respect to transverse ties. So all these connections, the whole purpose of showing this connection to the forum is that to understand that all this precast design information knowledge is available. It's already given in the Indian codes as well. There are some mandatory requirement which we all have to follow, and that's how we ensure that the building is behaving as good as if it's a cast in situ building, or even better in terms of any kind of electrical load situation, or also the smooth transfer of gravity load. So now I'll show you some precast projects examples in India. So this is one of the example of Pune, where there are 60 towers, 4 million square feet residential apartment. You can see photos. It's a Maharashtra Police Housing Colony. Unfortunately, the project is not completed yet because of its own issues with respect to, some issues which are happening with respect to the site and all. But otherwise, if you see, this is the project photo taken when the project was moving at full speed, and you can see that that how the construction is happening at site. You can see only hardly 10 people you can see at site who are actually doing the installation of the wall. So basically, if I explain the residential precast solution again, you can see that there's This is my load bearing wall, which is being installed here. And I have this dowel reinforcement coming out, which goes inside the wall panel, and then it's filled with the grout. And then this is where I have one-way precast slab, which you can actually see here in this photo, where this slab is coming and resting on the wall. And then in this entire area, the RCC topping is done. And then you keep repeating the same sequence. So you're actually able to achieve, I mean, theoretically, you can achieve 3-day cycle, slab cycle for residential construction, but practically people are able to achieve 6 to 7 days cycle with respect to precast construction. It's a closer look of that installation. And all your electrical conduits and everything would be pre-embedded. With respect to floor conduits, we are placing those floor conduits in the topping itself. You can see this is the topping thickness you can see from here. So all your electrical conduits in the floor are embedded inside the topping, and the wall conduits are embedded in the wall. So this was an example for a residential building. This is the Galaxy Tower. This is finished building. The project is already finished. It's leased out and tenants are already utilizing this property. So this one you can see it's a precast column beam structure where the single story precast column, then precast pre-stressed beam, and hollow core slab is spanning from beam to the beam, and then RCC topping is done on top of it. So this building is already finished, completed. Then this residential building is also based on wall frame structure, where we have used hollow core slab, wall, and stay flights in seismic zone 4, and it has been done up to 9-story in high seismic areas here. And that this 9-story was done as per their client requirement, but there is nothing to do with the limitation in respect to how high rise we can go. Now this is the warehouse example that I was talking about. So in this warehouse project, which is also completed, you can see the finished photographs here. Now in this, our structural scheme in the precast system is that my foundation are all isolated footings, which are precast. Then we have pedestal. And in warehouse, you have a plinth very high, like 1.2 meter high from the outside level, because in the docking area, you want trucks to come and then directly fit inside this slab on grade level. So even this 1.2 meter plinth beam was done with precast, and then this all around facade wall is with the precast. Then my columns are like 10 to 12 meter high, and then we have 2 levels of tie beam at this level and otherwise at this level. And all my internal columns, everything is precast. So only the roof part, which is lightweight, we kept it as steel structure, and rest everything is done in precast, including the mezzanine floor here. So that's all on the precast solution with respect to various buildings. I have one video to showcase before I end my presentation. This will give you a feel about mechanization of structural elements. So I'm going to run a small video. It's actually almost like an 8-minute video that how the hollow core slab production is done. And you'll understand that basically what kind of automation is happening in this kind of element production, which really increase the speed of construction, optimize your cost of production. And this is definitely a revolutionary product. So first thing is that we are using a basically zero slump concrete with respect to hollow core production. So in this hollow core slab plant, you have basically 1.2 meter width of a bed, and it's a long bed casting, long line casting. So the first process is that this entire long bed, which is basically a 120 meter to 150 meter long bed, you just clean the bed and you just oil them, and then you start placing the strands. So after cleaning and oiling, this machine is basically pulling the strands, and at one side it is locked, And on the other side, which is the active end, you are doing the pre-stressing. So this is a multi-stressor which basically pre-stress all these strands together with respect to this slab. So this is what happening.
You're showing the video now, sir.
Yeah.
Vaibhav ji?
Yes.
Video bata rahe na?
Ha. You're able to see the video, right?
No.
Sorry.
Oh, Mr. Siddharao also said that they can't see any video. I thought you had to show it. When you were talking, there was no video.
Just a second. Let me. Now you are able to see the screen?
Yeah. Take it back.
Oh.
Take it back.
Yeah.
The starting part, yeah.
Okay. So this is basically zero slump concrete. You can see how this ball is prepared. So it's just showing a zero slump concrete. So I'm saying that this hollow core plant is basically a long line casting where the width of hollow core bed is 1.2 meter. Now this machine is basically cleaning and oiling the bed, and afterwards is pulling the strands. So right now just cleaning and oiling the bed, and then the same machine is pulling the strands. So one person is doing this activity utilizing this machine. We call it a bed master. So you have, you get the strands in the coil form. You're able to stress them. Then we have a multi-stressor. So this multi-stressor is basically stressed all the strands together. So like you have got 4 or 5 strands in a hollow core slab width of 1.2 meters. So all these strands are stressed in one go. You don't need to stress it one by one. So, and then the pre-stressing start. So once the stressing is done as per the required force, then we just lock the this pre-stressing abutment area. Now this is an extruder machine, which basically will extrude the entire hollow core slab, which will keep on casting this hollow core slab. So it is a self-running. Is like once it starts, it will finish the bed in less than 2 hours kind of a time. Now this is a concrete transportation. So from batch mixing plant, this concrete shuttle has collected the concrete and it's transporting the concrete to the comcaster. Now this is the comcaster, which is basically transversely, it is distributing the concrete. So you can have number of beds of hollow core, and then this comcaster is feeding the concrete to the extruder. So you can see this horizontally is going and it's feeding to the extruder. So you can see there are 3 machines in function. One is the shuttle, other is this comcaster, and then the extruder. So these 3 are all in sync and they keep on casting the entire bed without any intervention, human intervention. So you keep receiving the concrete from the batch mixing plant, and this concrete shuttle will sync with the comcaster. Comcaster will move along with the extruder, and this entire process is happening automatically. And you can see that this slab is coming out from the machine like a ribbon, and it's a pre-stress. This hollow core slab just after the extrusion is so strong that somebody wants to walk can even walk on that top of the slab. So this is how the casting is happening. So in less than 2 hours, you're able to cast a 150-meter long bed. And then you can cast the next bed. So basically one extruder is able to cast in a day, let's say 6 beds you can cast in a 12-hour shift. So this is how the casting of this thing is happening. Then there's one more machine which can do the modification in the hollow core slab when the concrete is green. Let's say you want to take out some cutout, or as per the drawing, you want to create some modification in the slab. So when the concrete is green, this is modifier is able to do this, and it's also able to take that extra concrete back to the reutilization of this recycling purpose. Now, once the casting is done, we just put the tarpaulin for the curing purpose. Now, this is also very important that for curing, we are having a hot water circulation below the bed, so which we really increase the temperature of the concrete. And with that kind of a heated temperature, we are able to accelerate the curing process. And I'm able to achieve required strength of 35 MPa in 8 to 10 hours time. Obviously, it all also has to be done with respect to how the concrete mix is designed. But with the heated water circulation, we're able to increase the temperature and able to do the faster curing. Now, once the curing is completed, now we are in a position to cut the slab. So now this slab is cut as per the length requirement. So if I need a 6 meter length or 8 meter length or 4 meter length, so obviously as per the design, I'm able to cut this slab. This is a 360-degree cut, which can cut the slab in any direction of any shape. This is the cutting machine. So this takes care of the, and then after the cutting, you can see that the strands are just flushing with the concrete surface. That shows that there is no slippage in the slab, and then the slab is good to use. So after this concreting, you just take the slab and put it in the element transportation system. So this is my element transportation wagon. On top of it, I just put the slab, and then slab comes out. For quality check, we can also do the core cut in the slab in some of the samples and check the crushing strength of it. Then we understand what is the strength. So and then the slab is utilized for residential project or for commercial project or industrial project, and we just place this kind of stuff. So it's a very versatile product. 1.2 meter width, length can be as per project requirement. So, and this is easy to transport as well. And this entire plant only requires 10 to 12 people kind of a staff to produce, I would say, 1 million square feet slab every year. So that kind of a level of mechanization is possible, and it's already happening in India now, where now Elematic itself has supplied more than 35 precast plants, small and big. So that's it from my side. Thank you all. Thank you for giving this opportunity to present this solution. Thank you.
Yusuf ji, Mr. Yusuf Inamdar.
अनम्यूट केलं व्हिडिओ ऑफ केलं ना त्यामुळे तो व्हिडिओ ऑन कर ना तुमच्या फोटोचं सर
Madhu ji, Mr. Yusuf Inamdar. Madhu ji कहाँ हो गए? Mr. Madhusudan. Yusuf खोलना हो Yusuf Inamdar.
जवाब भाई यूसुफ इनामदार को फोन लगाओ अभी उनकी बारी आ गई ना लेकिन यहाँ से दिखते हैं यूसुफ भाई हाँ एक मिनट अग्रवाल
Yes, 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 yes.
Yes, चल हाँ unmute हो गया unmute नहीं हो रहा था उससे. Thank you. Good evening everybody. I think it's a beautiful presentation from Mr. Vaibhav Singhal. And yes, as a conclusion session, I have to add something. Yes, day by day we are facing a lot of difficulty of the skilled manpower. Then we are facing the issue of the different time zone for some of the areas where we could not work in the night shift or sometime in the day shift. Then as it is a precast factory, it's always have a better quality control. And as we are facing a lot of difficulties on site when we are casting such elements, the transportation of the concrete, then the placing of the reinforcement, placing of the concrete, etc. But it's in precast factory, it was a beautiful presentation, beautiful concept is there, and as it's a factory made product, each and every element, like foundation is there in precast, columns are in the precast, of course superstructure which called slabs and the precast. It was a very beautiful concept. Then first of all, we should thank Elematic. They have a better customized idea what the actual client or the customer demands, which we call the VOC, the voice of the customer. When we are the customer, like Elematic is helping us in the design, RCC design, then precast mold designing, the production series, then stockyard, then concrete mix design. Yes, there is a most essential parameter. Yes, insulated wall, that I have to mention, it is a very beautiful concept where yes, day by day we are facing the climate change, the temperature is increasing. So insulated walls are one of the best concept which I have seen in the presentation. Yes, facade, it was a very good, again, they have taken very good initiative to take care of the facade also. So if the facade and the insulated walls are there, definitely the structure's durability, it will be a very good, not a very good, it will be the best only. 2-3 points which we have to as an engineer or a contractor, we should talk about the cross criteria, as because lot of the contractors or the builders, they want to go with the financial criteria. If that is for them, it is a very essential. So I think Elematic should consider that what is the investment, what is the final cost of their product, which is more benefit to the builder or the end customer. So, and what will be the definition of a small plant and the bigger plant. So that was from my side, I think 2-3 points. And yes, now recently one code there which comes from ASTM, that the fiber reinforced polymer bars are coming, which is highly economical. So can that bars can be utilized in our this concept, precast concept. So this is one more things which I have to add. And but yes, overall the presentations are very good and it is a highly technical. And I request Elematic team that they should also plan something big for the infrastructure industry also, for the metros, the bridges, and underground also. Thank you.
Thank you, sir. Thank you, sir. Mr. Surajit Bhattacharya. Sir.
Yeah. Good evening, all of you there, and thanks very much for inviting me. And I'm happy to join. And this has been a very informative, insightful session so far. I have a small question, a few questions. And being an engineer, I have some other questions, but I think they are already taken care of. Now, my first question is that, like, we all know that people who are traveling all over the world see this prefabricated construction going on everywhere. It is not about time, and it's about the the ease of it. Is about the cleanliness, environmental factor that helps because in Singapore main city, if you have to do some construction, you cannot dump construction materials and work there. You have to quickly start and finish and things like that. In US also the same things happens. If you're constructing a project in a remote place, that's probably okay. So that really helps. But I see, being probably an old generation engineer, I find that the precast installation may require some specialized skills and some machineries to do that. And that is where you need not the standard construction workforce can work. So that is where you need for a specialized group of people to install. And also basically I'd like to know about the cost effectiveness in going for precast system vis-a-vis the normal system. So these are my questions to Mr. Vaibhav. Thank you.
All right. Shall I answer or?
Please.
Yeah, please.
Okay. Yeah, I understand, cost has always been the important part.
Vaibhavji, are you there?
Yeah, he's answering.
Yes. Am I audible?
Yeah, you're audible.
Okay. So yes, cost is an important parameter, but at the same time, when we evaluate the cost, it depends on many factors in terms of size and project and those kind of and location and those kind of things. But just to give you a feeler that where it will land up. So I would say compared to conventional cost of construction, the delta in precast is 10 to 15%. And this delta can be plus or minus. Okay, so when I say plus, so probably let's say your project is too small and you don't have the technology in hand, probably you are relying on a precast contractor who is probably wants to charge some premium as well. Or there is a logistics in such a way that your transportation cost is going up. So it can be 10-15% plus. But at the same time, it can be 10-15% minus or even more, like minus 20% as well. If you have a large size project, probably 2-3 million square feet to be developed in 2 years time, let's say. So you would be able to save 10-20% cost. I'll tell you how you are able to save it, because with respect to precast, we are eliminating 100% plaster work. So on RCC, there is no plaster happening. So that saves my cost. Secondly, I'm able to optimize concrete and steel consumption, especially when I'm using pre-stress strands. So with pre-stressing, I'm able to optimize my rebar consumption. As a ballpark, we have seen that in a floor system where it's a 8-meter span for commercial building, let's say, 8 or 11-meter span. So I'm able to save almost 1 kg per square feet steel compared to conventional construction with the uses of pre-stressed slab and pre-stressed beams. So effectively, this delta can be again 10-15%, but it has to be evaluated on a project to project basis. And with respect to the skill required for precast construction, so see, this is correct. In precast construction, we are reducing the manpower requirement to 25% compared to conventional. Now, but that 25% manpower is, I would say, semi-skilled or skilled manpower that we are working with. But at the end of the day, if I talk about production of elements, so we are still dealing with rebar, still dealing with concrete. So we need people who understand concrete and rebar. Then on top of it, there would be some training programs to operate machinery, which let's say Elematic is supplying with respect to hollow core production or some kind of automation. So that training has to be given. But it's not that very difficult. I would say that anybody who is good with conventional concrete construction and who's already having good knowledge about concrete formwork, they can easily be trained in a 4 to 6 weeks time, and they are useful. And that's how precast construction is happening all around.
Thank you. Mr. Sakthikumar, you had raised your hand, and Mr. Krishnani sir.
Yes, sir.
हाँ बोलिए.
सर पहले शक्ति कुमार सर बोलेंगे कि पहले मैं बोलूं?
Sakthikumar sir है?
Just wanted to give my appreciation to Vaibhav for putting up a very good presentation, making it simple for everybody to understand. Very well done. Thank you very much for imparting knowledge on Precast to all of us. Thank you very much.
No, I would like to ask a few words.
Yeah, please,
Hello?
please.
Should I continue?
Please continue, sir.
Yes. Really, thanks, President and Co-Chairman, for arranging such a nice meeting, for nice information of precast industry. I'm not getting a name who just now spoke about the precast.
Mr. Vaibhav.
Mr. Vaibhav, I want to just know about the reservoirs. Building industry, precast is going on. We are seeing that, but we have not seen single reservoir on precast method. Hello?
Mr.
Yes.
Vaibhav.
Yes.
Sir, are you getting me?
Yes.
Mr.
This about, I want to know about small capacity reservoirs. Can they be constructed on precast units?
Yes. See,
Elevated, listen, one second, I'm completing.
Yeah.
Presently, I am doing 50 the reservoirs. 50 the reservoirs, the capacity is very small. It is for villagers. Capacity is 20,000 to 1 lakh liters. Height is 15 to 20 meter. Have we done anywhere precast reservoir?
Yeah. So first of all, I would say we have done some concept for some customer on the reservoir side as well. It has not been implemented on ground yet. So I would say that it's at a concept stage that we are working on right now. But at the same time, even in reservoir, there are ways of doing it. Like first of all, when it is an overhead water tank, so below structure is still a column beam structure. Right?
Perfect.
So
Yeah.
all your column beam structure, which I explained that you can easily do column beam structure with precast. We have to just see the crane capacity, the logistics part, especially in that remote area, how it can be done. Accordingly, we can divide my column beam structure that way. So
yet it is not done.
Yes, but I believe L&T has already executed. Probably my colleague.
No, they are on FRP. They are on FRP. They are not on concrete. They are on FRP units. Yeah.
Okay.
Concrete we tried 30 years back on precast, but that time precast was not that common, and officers we are unable to consider the things. Now the things have taken place. Precast is in force. Please see if you can work on reservoirs. It is a basic requirement today, because one reservoir it takes more than 6 months to complete when the capacity is 50,000 liters.
Right.
So if it comes on precast, it will be helpful.
Definitely. So as I mentioned, we have done some.
It will be more helpful to Mr. Sushil Agrawal, who has managed all today's meeting.
Sir, I have started R&D on this subject. I have applied for patents also for overhead.
I'll be pioneer to raise this.
Right, sir. Thank you.
Yes, sir.
We'll have to work together. Rajuji, we'll have to work together. We'll have to take help of Elematic, Mr. Vaibhav.
30 years back we had started.
Yes.
30 years back we planned, but even the chamber for drainage line, that was not being considered by the government. Precast unit we did 30 years back.
We tried to invite some government officials also to for this webinar, so that they understand. They can understand that how it can be utilized. All this precast utilized for making various infrastructure projects.
Sir, I will try to add. I am Shri Tripathi from Delhi. We have been doing this RCC tanks also in UP. So in precast. So it is not a new thing.
Okay.
And it is done on hybrid basis. The whole structure and all is done in precast, and the top one is done with the galvanized tanks. You know. So,
staging portion you have done.
Yes. Staging portion all in precast, and this is being done.
What is the height and capacity, sir?
Sir, it is around 150 KL, 200 up to 200 KL we are doing.
2 lakh liter तक हो जाता है आपका.
हाँ जी. And
Means on 4 columns.
We'll have to
16
come
16
together.
How
meters
the beams
staging.
are joined to columns, sir?
So there are systems to join.
No,
We can
how the
connect. I can tell you.
No, how the columns and beams are joined, sir?
See, we can talk on that
We can
because
talk, we
there
can
are
talk.
couplers.
Sure.
We can talk on it.
Because see, UP, many people have done on FRP. That I'm getting because UP Jal Jeevan Mission, they have done that. I'm adapting here in Maharashtra. I'm trying for that. But they are not allowed. Those are on FRP.
Yeah, we can connect separately, and I can
Sure.
inform
Best,
you
best.
on that.
Yeah, I'll be happy. Yeah.
In
you.
UP, a lot of tanks have been at present around 40 tanks have been done by one of my clients, so it has been done.
Please, I'll be happy.
Yeah, sure.
Rather thankful.
Right. We'll connect, sir.
Sir.
Thank you.
I have one question for Mr. Vaibhav. Like, what is the level of standardization in precast? Like, can you pick up some products from the market and build your own structure? Like, or everything is to be tailor-made?
So with respect to standardization, first of all, this hollow core is quite standard product because my width is only 1.2 meter and length is only cut as per the requirement. But the precast plant owners, like whoever is precaster, their machinery is quite flexible in terms of whatever is customer requirement, they can produce that size of element. So if I give you an example, let's say if I talk about column, now my column size, whether it's a 300 by 600 or 600 by 600 or 500 by 500, same mold can be utilized to produce this different size of columns. So I don't need to make any changes in the column mold as such. So, but that trend is yet to happen in India. Overseas, this is the trend that there is a precaster who is only producing precast elements. They are not into building construction. They are just receiving the drawings from customer that this is my drawing for the element that you just produce and give it to me. So that's how the differentiation is overseas. But I think gradually now in India as well, this will catch up very fast where there are precasters who are only producing elements and they are contractor who are executing the project.
Hello.
Yeah.
We have one question in the chat box, Mr. Vaibhav.
Yes.
How will this technology improve employment opportunities? And second question is, are there any ITI courses which will develop skilled labor in this area, or does the company have its own training facility?
Right. So this is more of a, I mean, I would say there's this kind of a, I mean, whenever new technology comes into a market, it will basically remove the existing employment, but at the same time create new employment with the technology. It's a more of a disruption in the construction industry where people have to upgrade their skills with respect to precast. So now you would see more operators are required, more crane operators in the factory, at site, and probably for the transportation purpose. So you would need this kind of skill set people. You would need people who can do jointing of precast elements. So new skill set people would be required, and existing people can basically upgrade their skills and become more employable in terms of technology driven construction solution. With respect to skill set development, I am not aware if any ITI course is happening. I don't think there is none, but there have been some initiatives taken probably by large construction company in South where they are developing this kind of training program. We are also in touch with one of the institute where we want to develop training programs, but we have not so far started this on a larger scale. So it has been more on the, like, we have our own trained resources who are actually stationed in the client's factory, and we are actually providing training to their staff for the period of 2 months, 3 months. So that kind of a training program we are having, but not on the larger scale.
Okay. Mr. Sakthikumar has spoken. I think he's there. He's there.
Madhuji, I'm done. I'm fine. Thank you.
You're done. Okay. Sushil Agrawal ji, Ajay Gujar sahab आहेत का?
हाँ अजय गुजर जी आहेत ना.
Ladies and gentlemen, I think we'll now move on to the vote of thanks by Shri Ajay Gujar, Honorary Secretary, BAI Pune Centre. And no more questions, I hope. Okay, nobody has raised their hand. Mr. Ajay Gujar, the floor is yours.
Good evening, all. I, Ajay Gujar, Honorable Secretary, BAI Pune Centre, here to propose vote of thanks. First of all, I would like to thank Mr. Vaibhav Singhal for very detailed, technical, informative, still interesting presentation on precast technology, latest developments. And I would like to thank Mr. Sridhar Rao, Head Sales, Elematic India. Thanks to BAI's Mechanization and Modern Technology Committee, chaired by Shri VG Sakthikumar and Shri Sushil Agrawal, for organizing webinar much needed by fraternity. Thanks to participants in large numbers across Pan India, all office bearers, senior members, past president, past vice president, and all dignitaries attended. BI headquarter office staff, and special thanks to Shri on Zoom platform. Thank to all once again. Goodbye.
Thank you, everybody. You can all unmute yourself.
Yes, sir.
Hello.
Yes, sir.
Hello. Everybody can unmute themselves.
Hello, Agrawal ji.
Hello, sir. Yes, sir.
How are you?
Fine, sir.
Nice seminar.
Yes, sir. Yes, sir. Yes, sir. If like we feel that we can have continuation of or continual discussion on this topic, maybe.
नहीं सुनिए ना अग्रवाल साहब.
हाँ जी.
मैं एक दो शब्द बोलता हूँ.
बोलिए बोलिए.
इसको ज्यादा वैल्यूएबल करने के लिए ना सिर्फ प्रीकास्ट इंडस्ट्री तो अपने आम में आ गई है. प्रीकास्ट इंडस्ट्री के लिए अभी इंट्रोडक्शन की जरूरत नहीं है.
हाँ जी.
अभी अगली बार जब भी करेंगे ना तो वैभव सर को बोलिए ऐसी कौन कौन सा सेक्टर है जिसमें अभी तक प्रीकास्ट इंडस्ट्री नहीं पहुंची है.
हाँ जी.
इसमें जैसा हमारा सोचना था कि रिजर्वायर नहीं पहुंची है.
हाँ जी. हाँ जी.
किसी का बोलना था कि रिजर्वायर का हो गया है प्रीकास्ट का वर्किंग. तो अभी
अच्छी बात है ना.
आई एम सॉरी.
नहीं अच्छी बात है. अपने जानकारी मिलेगी अपने को उनसे मतलब जानना हो गया है.
ऐसे कौन कौन से सेक्टर है जैसा मैं देखता हूँ अभी रिजर्वायर के लिए तो अभी तक मुझे नहीं मिल गई है. WTB ट्रीटमेंट प्लांट के लिए मुझे कुछ आप भी करते हैं. ट्रीटमेंट प्लांट के लिए अभी अपने को कुछ नहीं मिल गया है प्रीकास्ट में. वो कास्ट एंड सेचुअल करते बैठना पड़ता है अपने को. ऐसी और बहुत सारी इंडस्ट्रीज होगी. रेडीमेड डैम बनाते हैं क्या यहाँ पर पानी रिटेन कर सके. रेडीमेड टैंक प्रीकास्ट अभी जैसा खेती में तालाब के लिए लगता है वो कुछ प्रीकास्ट दे सकते हैं क्या ये.
नहीं इनसे यही अपन पूछ रहे थे स्टैंडर्डाइजेशन जो है वो स्टैंडर्डाइजेशन का लेवल क्या है करके. क्यों जैसे मार्केट से हम लोग जैसे स्टील सेक्शन लेते हैं वैसे प्रीकास्ट कंक्रीट सेक्शन लेके हम लोग बिल्डिंग बना सकते हैं क्या. कुछ स्ट्रक्चर बना सकते हैं क्या. जैसे वाटर ट्रीटमेंट प्लांट है. जैसे हम लोगों को तो एक्चुअली वाटर सप्लाई स्कीम में हम लोगों को काफी चीजें हैं जो अभी प्रीकास्ट इंडस्ट्री में आई नहीं है अभी तक. जो क्या हम लोग उसका उस प्रीकास्ट टेक्नोलॉजी का उसमें इस्तेमाल कर सकते हैं क्या. क्योंकि बहुत बड़ा स्केल नहीं होगा लेकिन कुछ अगर स्टैंडर्डाइजेशन अगर है तो हम लोग उसकी हेल्प ले सकते हैं.
I think we'll end.
Yes, sir. Yes, sir.
Thank you. Thank you. Good night, everybody.
Yes,
Thank
sir.
you, Madhu
All
sir.
right.
Thank you,
sir.
Thank you, sir. Yes, sir.
Sushil ji, very well done, sir. Thank you, sir.
Thank you.
Thank you, sir.
We'll many more like this, sir.
Thank you.
Thank you very much.
Thank you, sir.
Thank you, sir. Thank you.